Pulls.
a block over a smooth surface.
Yeah.
The rope he is using to
Pull.
pull the block is an angle of 45
45.
degrees. And the block mass is 100 kilograms.
100 kilograms,
and
okay.
Tension in the rope is 100 newton. What
Right.
is the value of the
So
reaction
it's
force?
100 kilograms, like this,
Yeah.
and then there's 100 newtons like this. But because this is 45, this is 100 cos 45, which I know is this, and this is 100 sine 45, which I know is this. There's also a reaction force here, and there's a weight which is 100 G. So reaction plus 100 over root 2 should equal 100 G. So the answer here is 100 G minus 100 over root 2. Question?
Why is it R plus 100 over that thing equals 100?
Yeah, these are the two up forces. This force is going up, and this force is going up, and it must equal this force going down.
But it's not equal because it's moving.
But it's not moving vertically. It's only moving horizontally. This is the thing.
So the resultant force is always up.
The reaction force. Yeah. Usually, but not always.
Because it's moving horizontally.
Yeah, it's not moving vertically.
So up force is.
Yes, yes. So did you get 910 newtons?
Yes.
No.
Okay. Grace, you can give me the second question. You can read it. You're Grace, aren't you? Grace.
Woman pulls a 100 kilogram block over a
Rough surface.
The rock shape illuminates an angle of 30 degrees with the ground. And tension in the rock is 200 newtons. What is the value of the friction force?
Friction. So there's a reaction, and then there's also the weight. What did you say the mass was? 100, was it?
Yes.
100 G, and there's a friction force. I'll just write F for friction.
How did you get the R for the first one?
This one?
Yeah.
This number minus this number.
Yeah, it's supposed to be, that number is supposed to be 100 sine 45, right?
Yeah, that's 1 over root 2.
Yeah, it's 100 sine 45, right?
Yeah, 100 sine 45 is this number.
Yeah, but then it's 100 minus 100.
That's 100 G.
Sine.
100 G.
So we change it to.
G is 9.81.
Okay.
Yeah.
You have to times it, right?
This is 981 on the right. 100 G. Yeah. Wait, what? Yes?
I don't know if this is right or not.
WMG 100, 9.81, 100 cos 45. No. So you got the right answer the wrong way. Congratulations. Let me fix it. Give me your pencil. Right. So this part is right.
Yes.
This part is right. But you need to also do this part. So this part, you see this number here? That's here, 707. Or what's it, 70.7? You need to calculate this one, which would be 100 times sine 45. So you say this plus this equals this.
Oh, okay.
Yeah? Yeah.
So it's 100 kg, right? So the force that's acting down is supposed to be 100 times 9.81,
Yes.
right? Yeah, so it's 100 times 9.81.
Yes. Yeah.
And it's 981.
Which is what I said, yes.
So 981 is supposed to minus.
Yes.
Sine.
Yes.
100 sine 45. Okay.
Dude. Right. So here What can we say about this one? We want the friction force going to the back. So we know that the friction force must equal this force here.
Yes.
Yes. Because it's moving at a constant speed. At least I hope I said that in the question.
Yeah.
Yeah.
Yeah. So we should have 173 newtons.
Yeah.
That's exciting. Okay. Sohi, can you give me number 3 when you're ready? What's the story for number 3?
Woven pulls 100 kilograms rope over a rough surface.
Mhm.
The rope she is using makes an angle of 30 degrees with the ground,
Mhm.
and the tension in the rope is 200 newtons.
Uh-huh.
The friction force is 1/10 the friction force.
Ah.
What is the acceleration?
So here I say the friction force is 1/10 of the reaction force. The weight here is 100 G. So what you can say is, number 1, that 100 G plus 200 sine 30, what should that equal? What the heck? Sorry, I'm getting my diagrams mixed up. Or plus 200 sine 30 equals 200 equals 100 G.
Yeah.
Everybody's happy with that. Now here, please be careful. The block is accelerating. So it is wrong to say that this equals this. It does not. What you can say though is that F is equal to 200 cos 30 minus a tenth or. So I'll give you a moment, just make sure you're okay with that.
The R is the friction, right?
The 1/10 or is the friction.
Okay.
I just get the drag force.
Yep.
And then multiply 10 over 1.
Get the reaction force and multiply by 1/10. Yep. And then you take that answer and put it in here. So 100 times 9.81 minus 200 sine 30. Okay, so divided by 10. So I got this part here is 88.1 newtons. So you get F equals 200 cos 30 minus 88.1. So I got F is 85.1 or 85.2 newtons. But what does F equal from Newton's second law? That's ma. So then the A, your answer is 0.852.
Why is 200 cosine 30 is, it should be bigger than the left.
Yes, this one is bigger than this one. Correct. Is this what you're asking?
Yes.
Yeah. And so this 88.1 is just this part here, and I used my answer here. I just, took this over. What do you mean, huh? What's wrong? Problem?
No.
Are you sure?
ATF1.
So this force is bigger than
This 85.2 is the answer you get after you do this one minus this one. So this 85.2 is this minus this.
Yes, okay.
Yeah. Because I typed in 200 cos minus 88.1 and I got this answer.
But this force is from where?
This one? This one here?
Yeah.
This force is this one minus this one.
Yeah. So
Yeah.
if I draw the picture.
Oh, if you draw the picture, yeah, it's like this.
Just like this.
and the force here and here cancel, and the force here you don't draw in because you already took it away from this. So the block looks like this. This is the simple diagram for what's happening.
So even if it's the side one, why is it R plus 200? Oh, okay, I understand. Yeah.
Do you?
Yeah, I do.
You're not just saying that?
No, I understand because
Okay.
first you find the vertical one and then you find the horizontal one.
Basically, yeah. This is okay.
Something will become done.
So the vertical forces and the vertical resultant force and the horizontal resultant force is the same.
The upwards vertical must equal the downwards vertical because it's not moving vertically. However, this is accelerating to the right, so therefore the force to the right needs to be bigger than the force to the left. And it is exactly 85.2 newtons bigger.
Okay.
Not exactly. Okay, can I do the next one?
Yes.
How many did I give you?
3.
Oh, 5, well, 5 for
Oh, sorry, you told us that how many did I do?
Yeah.
Yes, down to 4. Okay, can you have you got the fourth one written
Yeah.
down? Oh, you have it there? Is it another block question?
Helicopter question.
Oh, okay, it's a little more interesting.
No.
Yeah, right, so you got your helicopter, there it is there. Right, so tell me what's happening with the helicopter.
A 45 kg woman is sitting on a helicopter that is about to take off. The helicopter takes off with acceleration of 5 meters per second square.
Yep.
What is the reaction force between her
And the helicopter. And the seat. Look, I'll even draw in the seat for you. There we go. Standard helicopter seat, yes. And the seat is a little bit outside the helicopter, I know. So there's a reaction force here of 4, and there's a downward force. What's her mass, did you say? 45 G. So which way is this woman moving if the helicopter is going up? Well, she's moving up as well. So this means that now we won't make a mistake again like last time. The R is bigger than 45 G. So the total force is R minus 45 G, which must equal MA. So that means R equals 45 G plus MA. Now we know the M, it's 45. And we know the A, it's 5. So a quick calculation here.
But that's just the mass of the woman, not the whole helicopter.
Yes, I know. And it seems a bit weird that you're not looking at the mass of the helicopter. But through the point of view of the woman, the mass of the helicopter is not important because the woman only feels 2 forces on her. The seat pushing up and the earth pulling down. So if I was to push you, you don't care about what my mass is, but just how much force I'm applying to you. Okay, is this okay?
What about 5 meters per second?
There it is there. It's the A. Yeah? Okay. Give me the last one as well, so since you have it on your phone there.
A 70 kg man is standing on a scale in the elevator. It takes the elevator 4 seconds to move up 1 floor, a distance of 5 meters. What does the scale say when the man's mass is? I'm going to answer the last part. What does the scale say?
Say his mass is.
Oh, scale, yeah.
And what did you say the journey was? How long did it take to travel?
4 seconds.
4 seconds to
move
travel.
up 1 floor, a distance of 5 meters.
5 meters. Okay, so we have UVATS 0.
We
Don't know. Don't know. Yes, we know. Yes, we know. Right, so I want the A. V squared. No. S equals UT plus a half A T squared. So A is 5 over 8. So that's his acceleration upwards. Yeah? So there's a force here, and there's a force here, 70G. Which is bigger? Or. So you have F equals or minus 70G. So you have MA equals or minus 70G. So the or equals 5 times 70 divided by 8 plus 70 times 9.81. So I got the or is 730.45 newtons. Now, if this man was just standing still, not moving, then what does the or equal? It should just equal 70G if he's not moving, right? So here the or should equal 70G. So the reaction force should be 686.7 newtons. So how much bigger is this? Well, if I do 730.45 divided by 686.7, this is 6.4% bigger, the reaction. So that means the weighing scales will think he's also 6.4% bigger, because the weighing scales just uses the reaction force to calculate the mass. So the weighing scales thinks he is 74.5 kilograms.
Why is 16.4?
Oh, I got the percentage. You know percentage?
Yes.
So I just did 730.
No, and how to 66?
Yeah, I'm showing you. 730.45 divided by 686.7. Oh well, you know what? No, I'll make it easier for you. You do 730.45 minus 686.7 divided by 686.7 times 100 over 1. You know, like what you learn in middle school. Yeah? No?
This is define the percentage, right?
Yeah, find the percentage.
This question is asked to find a percent?
No, I need to find the percent to get this answer.
Why?
Where is the answer from?
This is the final answer. This is the reaction if the lift was not moving.
Yeah. And
This is the reaction if it is moving.
Yeah.
This is 6% more than this. That means the weighing scale thinks he's heavier by 6%. Because a weighing scale calculates the mass by using the reaction force. So if the reaction force is bigger, the weighing scale thinks its mass is bigger. The weighing scale doesn't know that it's moving.
So what is it UV ATS? Like A T is time.
T is time, S is distance. Yeah.
And U is?
Initial velocity.
Initial velocity is
Final velocity, yeah.
Okay.
Yeah.
So using equation of motion we find that.
Oh yes. Yeah.
Okay.
Yeah. Unfortunately, that was what we did at the start. Yeah. The UV ATS formulas. Yeah. You've probably done them in physics before, have you?
Yeah, done.
Yeah. Okay, you got this?
No.
Well, hurry up.
So we got the reaction force minus and then we convert it into mass.
Yeah, basically, yeah, you got a reaction. Yeah, look, if you didn't want to do percentages, you could do it this way as well. Look up. Look, I'm going backwards in time. If you didn't want to do it as percentages, you can do it like this. If the reaction is 730.45, the weighing scale thinks his mass can be found by using the formula mg equals this. So another way of doing it is by saying that the m should equal 730.45 divided by g. So let's see, 730.45 divided by g. So that's the same answer, 74.5 newtons. If you want to think about it that way as well. Can I close it? No.
No.
Do I have two homeworks or one homework to do?
One homework.
Oh, good. What's wrong, Grace?
I'm looking.
Looking for what?
Problem.
Yeah, I see a problem.
Is it Newton?
That's a... No, it's not. Thanks, Sophie. That's a kilogram.
So the weight is equal reference? No, the equal reaction force?
Yes. That's what the weighing scale thinks.
So if the resultant torque is 730 point something, that's the newtons, right?
Yeah.
Yeah. So his weight also show the same mass. I mean force. Same weight.
The
Right?
weighing scale thinks the weight equals the reaction force.
Okay. So we just have to change it to mass.
Yeah. Yeah. Yes. Are we just waiting for Amanda? How much time do you need?
30 seconds?
Okay.
Oh, finish.
Finish breakfast? First breakfast or second breakfast?
Reference.
First breakfast.
80%.
80% full. Still 20% though. Yeah.
Waiting for lunch.
Ah, good, yes. Okay. We can continue, Amanda?